in chapter 3 section, do you see that it actually has all of that information?
Yes.
Okay, there is a right triangle, and it tells you what sine, cosine, and tangent are. So you know that you always have access to that. For every test, you'll have access to your equation sheet, okay? For every homework assignment, you've got it, so it's always there for you, okay? So you don't have to have this memorized. If you have it memorized, great, it's just going to make your life go faster, okay? But it's there if you need it. Questions there before we actually use this thing? Is everybody okay so far? Okay. So, now we have to go back and figure out why did she go on this little rant here. Well, we're trying to find this angle theta. It might be helpful to mark the right angle in your triangle, and then we just need to look at what we know and what we have and what we can use. I want to find theta. I know this side. What side is this relative to that theta?
Opposite side.
The opposite side. And I know this side. I know this one is the adjacent. So I look at my little sheet or I look at my notes and I see that opposite and adjacent are related to which of the trig functions? Tangent. So right now I'm going to write it down. I want you to write it down too. Play with me here. Tangent of theta is equal to the opposite side, which is, in this triangle, is how big? 8 meters. Divided by the adjacent side, which is 6 meters. Okay? So far, so good? Okay? Now I want to get theta all by itself. Just like with any algebra problem, if I'm trying to get a value all by itself or a variable all by itself, you have to undo things that are happening to it, right? So as a complete aside, but just to kind of get your brain in here, if I have x plus 3 equals 7 and I want to get x all by itself, what do I have to do? Subtract 3, right? That's because addition and subtraction are opposites, or the technical word would be inverse operations. Yeah. If I had 2y equals 100, what do I need to do to undo multiplying? Divide by, right? Multiplying and dividing are inverse operations. If I have z squared equals 49, how do I get z all by itself? Square root. Square root is the inverse of squared. Is this okay? So then we need to do the inverse of tangent. And it doesn't really have a very fancy name except inverse tangent. So it's like really easy to remember, right? Because it's just the inverse of it. You can find all of the trig functions and their inverses on your calculator. Pull out the calculator that you're going to use. And I'm going to make a couple of quick statements. The first statement is that I have used, but I am not an expert in the fancy pants calculator that is known as the Inspire whatever, okay? I do know that students have had trouble with the Inspire because it will not always stay in degree mode. For everything that we are going to do, we need things in degree mode, okay? I'm sure that there are experts among you that know how to change it from radians to degrees, but I've tried and I just don't use it enough to have that expertise. So, if you know how, or if you can find somebody to help you, fabulous, that's great. I'm not saying you shouldn't use it. If it's a struggle for you, then just use a simpler calculator. Is that okay? Does that make sense? Okay? I'm not saying you can't use that. I'm just saying I have, in other times, spent 45 minutes trying to figure it out, and that's a waste of our time. Okay? On the simpler calculators, it doesn't have to be this simple. It can be a little bit more complicated. Do you all see the buttons that say sine, cosine, and tangent? Okay? And right above them, kind of painted on the plastic, it says sine -1, cosine -1, tangent -1. Those are the inverses. So to undo tangent, we're going to say that theta is equal to the tan inverse of 8 over 6. So to get rid of tan here, I'm going to write tan inverse on the other side. So to find theta on your calculator, you're going to do tan inverse, and to get up there, you hit second, and then the tan button, and that will get you tan inverse. And then in parentheses, go ahead and say 8 over 6. I want to make sure everybody's able to do this. So I'm going to pause for just a minute. I want to make sure you've got it. Once you've got it, check with your neighbor and make sure that you all agree with the same answer. So we get 53 degrees, and then there's one more thing we have to do. What? It seems like it's taken forever. We already had this a long time ago. The 10 meters. We've got the 53 degrees, so I'm going to put that up there. At 53 degrees. But at 53 degrees, what? That's what we need to know. This is the last component, this is the last piece that you have to know how to do. It's not hard if you pay attention, so stay with me right now. Focus up here right now. I want you to take a look at what's going to happen. I want you to take your pencil, and on your picture, I want you to point it on the x-axis, so it's pointing east. You don't have to do this every time, it just helps, it's a visual thing. It helps many people. So right now, you're pointed east. You agree? Now I want you to align your pencil with the resultant. In doing so, what did you have to do? Where did you have to go? 53 degrees, which way? South. Does that make sense? So the direction you're going to write down is 53 degrees south of east. You with me there? So it's going to be south of east. That's how it works. We'll go through it a few more times so that you understand, like we'll practice it some more. Okay? But that's the rule. You're going to start on one of the axes and then move your pencil or just kind of move your eye down and note which way you're moving. Okay? So this is kind of a slow start since we just are finishing a problem. So let's try one like a brand new one and see how we do. Is that okay? Here it comes. While on an adventure in his car, Bunsen Honeydew, so this is Beaker's cohort, right? The guy with the big green head. Looks like a honeydew melon, hence the name. Okay? Traveled west 6.2 kilometers, then 3.1 kilometers south, and then finally west another 4.2 kilometers. The question says, what is his total displacement? So what would you do first in order to solve this problem? Any ideas?
Make a picture.
I think a picture is in order. Yeah, draw a picture. Okay? Give it a shot. Talk to your table mates. I'm going to work it out up here as well. If you have questions, advocate for yourself. Ask your table mates, ask me. Okay? Go, go, go. Once you've got your picture, before you try to start going further, do check with your partners and see if their picture matches yours. The other recommendation I would give you is to not be afraid to draw a big picture. Big pictures are going to be helpful. If you try and draw it and it's only like an inch square, it's going to be really hard to see what's going on. Okay? And I generally start with an axis so that I know where I'm going from. person that's next to you is a resource. Talk to them. Help each other out. You could approach differently than I did, and that is completely fine. The big one, is that you could have used a different triangle. You could use a triangle that goes over here, and down like that. Right? Is that wrong?
No.
Absolutely not. They're both correct. You're going to get the same hypotenuse either way, because I'm sure in geometry you prove that the diagonal is going to be the same whichever triangle you use. We could write some proof for that or something like that. The thing that will be different is that you'd probably solve for this angle here, and so you're going to get something different, right? Like the complement of this one. So instead of 73, you get something like 17. 17 plus 73 equals, whoa, that's amazing, right? And then your directions are going to be the other way. It would be south of west. Is that okay? Is that making sense? Yeah? Okay. I want to try this a little bit more. I want you to practice a little bit more, okay? We're going to do a couple problems in the book, and then we're going to make it a little bit more fun. So, on page 91, with your partners, I want you to take a look at these two problems, number 2 and number 4. Page 91, I know, wow. Is what we've just done, which is taking a bunch of vectors and putting them together to build a resultant. Do you feel like you've figured that out, or at least have a start to figuring that part out? Okay? If you're still working on it, there's some homework that will help you there, okay, that will get you there, and we can keep practicing. The other thing that we need to know how to do is what we call breaking a vector into components. And this example will get us there. So this says that Skeeter has a total displacement. I'm going to make this a little bit bigger so you can see it better. That's bigger. Okay. Total displacement of 15.5 meters at 31.7 degrees north of east. So it's kind of working backwards. This says, how far did he go north? How far did he go east? So I want to walk this one through with you, and then we're going to try some of these kind of things on our own together. Does that make sense? So for this kind of problem, go ahead and draw your axis, just like we have in the past. And figuring out where to draw this vector is really quite important. We know the magnitude, the size, is 15.5. But you can draw a 15.5 meter vector any which way, right? The thing we really care about here is the direction. 31.7 degrees north of east. So which way are you going to start facing? East. So go ahead. Oops, sorry. Put your pencil facing east. And then turn it 31.7 degrees north from there. That's the direction that your vector should go. Does that make sense? So again, you're going to face it east and then turn it north. Okay? And once you know that direction, then you can go ahead and draw the vector. It's going to look something like that. So this is 15.5 meters at 31.7 degrees, and the north of east is kind of in there. So we're taking that vector, and now we're going to break it down. Instead of cutting across all of the people's yards, when Skeeter was walking from his house to his friend's house, let's say that he walked straight east first and then went north. We want to know how far he went in each direction. Okay? So let's go ahead and draw this. So let's go ahead and draw a vector east. And then another one that points north. And those two vectors are the components of the red one. How are we going to figure out how big the blue and the green ones are? Sean, what do you want to do?
By using 15.5 multiplied by the sine of 31.7.
Whoa, you just did a lot of stuff in your head there. Can you back us up and walk us through what you did to get there?
Sine 31.7 is equal to...
Sine of 31.7.
Opposite over 15.5.
Okay, yes, I should have been writing this in the other color, but that's okay. Yeah, so this one here, the y part, and I can just call that maybe y. That's easy. The opposite over the hypotenuse. Does that make sense to everybody? So the definition of sine is opposite over hypotenuse. So there's my opposite over my hypotenuse. And then I just need to get y all by itself. How do I undo dividing by 15.5? Multiply by 15.5. So in your calculator, you don't need to do the inverse stuff this time. It's just going to be 15.5 times the sine of 31.7. Okay. Go ahead and plug that in. Once you've gotten the y piece, then try to do the x one. Talk to your neighbor, see if you can help each other out to figure out what to do for the x part. Yeah, go ahead. Krista, what's up, hon? Oh, yeah, of course. Yeah. Sorry, that was like a big question. Calculator question. Yeah, so I think I would do 30.7. And then multiply that by Yeah. Did you figure that for your Are you okay? Yeah? What did you get for the X piece? 13 point what? So we'd say 8.14 meters north and 13.2 meters east. All right. Now, we have a choice. We can either do another book problem that's very simple and looks like this, or I can throw you at a problem that's a little bit more challenging, but I think you're ready for. Can we try the challenging one? If you're going like, ooh, that's kind of scary, we're going to take it one step at a time. You're going to draw a picture, figure out what you, like, do it one little thing at a time, you'll be fine. The problem that I really am excited about is on page 97, number 3. Page 97, number 3. Work with your partners on this. Give it a shot. I think you can do it. This is as hard as these problems will get. Okay, I promise. Yeah, what's up?
For A, is it saying that it's north 10 kilometers and east 10 kilometers?
Oh, I'm doing the one in the box. In the brown box at the top.
Oh, that's why.
Oh! Let me clarify that. Whenever we do problems, we're always doing them in the ugly brown boxes. Sorry, I meant to say that and I forgot. This is the rodeo clown problem. So if you started doing the other one, I apologize. My fault. Ugly brown box problems. Always ugly brown box. Sorry about that. Better to, I'm glad that you asked that question now as opposed to like 5 minutes from now. Yeah. What's that? We have like 4 minutes left. So if you can wait, great. If not, go. So just to kind of get you started, if you're not sure, whatever, this is what your picture should look like, something like that. You'll need to break stuff into components first from that second piece, and then make a nice big triangle. Oh, Anna, I'm sorry. Somebody had asked last chapter, and I thought that I said this, but maybe I didn't. When you are doing pieces and you are doing calculations in the middle, don't worry about sig figs until the very end. Don't round until the very end. So like when I'm doing this component piece here, I'm just going to write this out to a bunch of sig figs for now so that I don't round, I don't lose any information until I'm done. Okay?